Question 2.39. A rabbit runs in a garden such that x and y component of its displacement as function of times are given by x equals negative 0.45 t squared minus 6.5 t plus 25 and y equals 0.35 t squared plus 8.3 t plus 34. Both x and y are in meters and t is in seconds. The first part of the question wants us to find the rabbit's position. So here they have given you the position function x and y, and we need to find its position both magnitude and direction at t equals 10 seconds. So let us calculate the value of x and y at t equals 10 seconds, and then we will find the magnitude and direction. So x component of position function is negative 0.45 t squared minus 6.5 t plus 25. So we can find the value of x at time t equals 10 seconds by substituting t as 10 here. So we get negative 0.45 10 squared minus 6.5 times 10 plus 25. That gives you the value of x equals negative 85 meter. Then we find the y value. Y component is given as 0.35 t squared plus 8.3 t plus 34. We will find y at 10 seconds by substituting time t as 10. So 0.35 10 squared plus 8.3 times 10 plus 34. And this gives you y component of position to be equal to 152 meter. After we find the x and y component of position, we can find the magnitude of position by using Pythagorean theorem. So I get the magnitude r as square root x squared plus y squared. That gives you square root negative 85 squared plus 152 squared. So magnitude of position is equal to 174.15 meter. After finding the magnitude, now we will find the direction, which can be found by using theta equals tan inverse y over x. So that gives you theta as tan inverse. Y component is 152, x is negative 85. That gives you the theta as negative 60.786 degree, or you can round this off to negative 60.79 degree. So this is my angle theta. Now if you were to sketch a rough graph of this position vector, this is y, this is x, this is negative x. Here the x component of position is negative, whereas the y component is positive. So my final position vector lies somewhere in the second quadrant, and the angle theta is this angle, the angle it makes with the x-axis. So if I were to state the direction, we know positive y is north and negative x is west. So we can say that the position vector is making an angle theta of 60.79 degree north of west. Because here the angle theta begins from west going towards north. So we can give the direction of this position vector as 60.79 degree north of west. Then in part B, we need to calculate the rabbit's velocity at 10 seconds. So first we are going to use the x and y component of position to find the x and y component of velocity by taking derivative of this position function. Then we will calculate the final velocity. So let us start with the x component. X component of position is negative 0.45 t squared minus 6.5 t plus 25. We can find the x component of velocity by taking derivative of this position function. So Negative 0.45 is a constant, we keep it as it is. Derivative of t squared is 2 times t minus 6.5 remains as it is. Derivative of just t is 1 plus 25 is a constant without t, so its derivative will be 0. So we get velocity along x-axis to be equal to negative 0.90 t minus 6.5. This is the velocity function. Then we find x component of velocity by substituting time t here. Time t is 10 seconds, so we substitute negative 0.90 times 10 minus 6.5. That gives you x component of velocity to be equal to negative 15.5 meter per second. Now we do the same thing to find the y component of velocity. So we write y component of position as 0.35 t squared plus 8.3 t plus 34. Y component of velocity we find by taking derivative of y. So 0.35 remains as it is a constant. Derivative of t squared is 2t plus 8.3 remains as it is. Derivative of t is 1 plus 34 is a constant which is not multiplied to t, so its derivative will be 0. So we get Vy equals 0.70t plus 8.3. This is the y component of velocity. So we can find its magnitude at 10 seconds by substituting t as 10. So 0.70 times 10 plus 8.3. That gives you velocity along y-axis to be equal to 15.3 meter per seconds. After we find the x and y component of velocity, now we will find the magnitude of final velocity at 10 seconds. So we get v to be equal to square root vx squared plus vy squared, which is equal to square root. Vx is negative 15.5 squared. Vy is 15.3 squared. So we get velocity v to be equal to 21.77, which you can round off to 21.8 meter per second. So this is the magnitude of velocity. We need to find the direction also. Direction we can find by using the angle theta. We know theta will be tan inverse the y component of velocity over the x component. So that will be tan inverse. Y component is 15.3, x is negative 15.5. That gives you the value of theta to be equal to negative 44.6 degree. Now, how do you show direction? Again, we will roughly sketch the graph for velocity. Let's say this is my y-axis, positive y-axis. This is negative x. This is positive x. We also know that positive y-axis will be taken as north. Negative x is west. Positive x is east. And this is south. Velocity vector has positive y component and negative x component. So it will lie somewhere in the second quadrant here, making an angle theta with negative x-axis. And this is the angle theta, 44.6. So since it is making angle theta with negative x-axis, we say it is starting from west going towards north. So the direction here will be 44.6 degree going north of west. West because we are starting from the negative x-axis. In part C, we have to determine the acceleration vector at t equals 10 seconds. Now, if they ask you to find acceleration vector, that means you will find both magnitude and direction. We can find acceleration by taking derivative of the velocity function here. So we will find first ax, ay, and then find its magnitude. So let's find ax. Acceleration along x-axis will be derivative of velocity along x-axis. So we keep negative 0.90 as it is. Derivative of just t is 1. Negative 6.5 is not multiplied to t. So derivative of a constant like this will be 0. So you get ax to be equal to negative 0.90 meter per second squared. Here there is no t present in the final answer, so I don't need to substitute time t as 10 seconds. This will be my answer for acceleration. Then we do the same thing for ay. Ay will be dvy over dt, which is derivative of the y component of velocity. So we keep 0.70 as it is. Derivative of just t is 1. 8.3 is a constant which is not multiplied with time. So derivative of 8.3 will be 0. So you are left with ay equals 0.70 meter per second squared. Again, there is no time t here, so we don't need to substitute 10 seconds. Acceleration along y will be this value. After we find the x and y component of acceleration, we find the resultant square root ax squared plus ay squared, which is equal to square root negative 0.90 squared plus 0.70 squared. Remember, if you're putting the negative sign here, you have to put it inside the bracket and not outside of it. After you solve this, you get the total acceleration to be equal to 1.14 meter per second squared. Then we find its direction. So direction we find by using angle theta equals tan inverse ay over ax, which is tan inverse 0.70 over negative 0.90. That gives you the angle as negative 37.87 degree. Again, if you want to show direction, we will roughly plot acceleration here. This is y, negative x. The reason I'm choosing y and negative x-axis because if you look at the values of ax and ay, ax is negative, ay is positive. So your acceleration vector lies somewhere in the second quadrant, making an angle theta of 37.87 degree with the negative x-axis. Positive y-axis is taken as north. Negative x-axis is west. So you can say the direction of the acceleration vector is 37.87 degree north of west, as the angle theta is starting from west here moving towards north.